Welcome everybody. We have this question, so let me draw the figure for this. We'll use here is the tangent theorem. So by this theorem, the radius makes an angle of a 90 degree with the tangent to the circle. So there is a 90 degree hit here. Okay, so this is obviously the radius r. Next, what I wish to do is I will connect the center of the circle to the vertex. So clearly this is a right triangle. So if I were to take this point as say some A, O, A and B, OAB is a, or I would say triangle OAB is right angled. So by Pythagoras law we have, so what do we have? We got OA squared plus AB squared is equal to OB squared, which means OA squared is R squared. This distance is given as 91, so 91 squared is equal to OB squared. We can retain it as OB squared for the time being, or what you can do is you can have OB squared to be taken as some side B. So I will consider this as some side B. So that means R squared plus 91 squared is equal to B squared. Now the next step what I wish to do is I would like to consider the next tangent. Clearly I can draw the perpendicular. So I draw a perpendicular, and then from this vertex I will connect it to the center. So this is clearly 90 degree. I'm going to consider this point as some P, and this distance, this length as some capital C, and already we have this point as B, so I have taken it as B here. So what I will do is, just for sake of uniformity, I am going to use the hypotenuse side as say Q, R, S and T. So let this be taken as some side Q. So this is going to be Q, and this is going to be R, and this point will be as C. So consider triangle OPC. Okay. So by Pythagoras law, what happens? By Pythagoras law, we got R squared, right? R squared plus X squared is equal to this distance, which is OC squared. Now we are going to consider it as R squared, right? So I have equation 1, equation 2, right? So next I'm going to again consider, say, this side. See, there is a tangency here, so I can actually draw a perpendicular. So this will be 90 and connect it to the triangle, or I would say make it as a triangle by connecting the center to the vertex. So this point is going to be D. As I mentioned to you, QRS, I would be taking this as S. Okay, so consider O, and this distance is 9, so I'm trying to name this point as some T. Okay, so we consider triangle OTD. So clearly this distance is going to be R, right? And this is given as 9, so R squared plus 9 squared is equal to S squared. So this is equation 3, right? So now again we will what we will do is we will draw a perpendicular here to this point. We can name it as some U. Actually I can't take it as T here because we are going to use T already here, so I will use some V. So consider OVD. So you connect this, and I'll take this as E. So consider OUE. So this is going to be R, and this distance is 21. So R squared plus 21 squared is equal to T. We will take this as T. So this is going to be 4. So this is what we have got. So 4 equations have been obtained here. So now what I'm going to be doing is I'm going to be considering triangle COD, and then I will drop a perpendicular. So if I drop a perpendicular here, I would actually get the height for this triangle, right? So let's do that. So I will drop a perpendicular from O to BC. Right? So we are creating a right triangle. So let me have this as base, and I will take this as height. So we will be utilizing this property, and if this is height h2, then this will also be reflected here. Height will be h2 here, and if this is b1, then this is, or I would say this is base 2, because b1 is already taken. If this is base 2, this base 2 will also be reflected here, and in this case it will be h1, and in this case it will be h2. Okay, so much so for the base. Of course you can also have this as b2 and this one as b1. Now what we are going to do is we are going to be considering this triangle. This is 90 degree. So from this triangle, what do we have here? We got b1 squared plus h1 squared is equal to q squared. From this triangle we got b1 squared plus h2 squared is equal to r squared. Now coming to this triangle, okay, because we have included r with this triangle, because the height changes but the base remains the same. Okay, fair enough. So from here, if I were to write r squared would be equal to b1 squared plus h2 squared. So this is the next variation for r squared. So moving over here, I got s squared is equal to h2 squared plus b2 squared, and over here I got s squared is equal to h2 squared plus b2 squared. So this is going to be h2 squared b2 squared, and this is going to be h2 squared and b2 squared. So from here t squared is going to be equal to bt squared plus h1 squared. The value for t squared will also be the same, so b2 squared plus h1, so no need to repeat it. So this is actually a repeat here, and even for r squared this has been repeated, right? So sufficient that we retain only one component. So I'm going to rewrite it all. So b1 squared plus h1 squared is equal to q squared. For r squared it is b1 squared plus h2 squared. For s squared it is b2 squared plus h2 squared. For t squared it is b2 squared plus h1 squared. So this is what we have got. So what I'm going to do is I'm going to eliminate the parameters. Okay, so if I were to consider q squared negative r squared, then b1 squared plus h1 squared negative b1 squared plus h2 squared. So b1 squared goes off. I get h1 squared minus h2 squared is q squared negative r squared. Now if I were to consider s squared negative t squared, this will be b2 squared plus h2 squared minus b2 squared minus h1 squared. So b2 squared goes off, giving you h2 squared negative h1 squared. Clearly if I were to take this as 1 and 2, from 1 and 2 what do we have? We got q squared negative r squared is equal to s squared negative t squared. This is what we have got. Okay, fair enough. But we know that q squared is equal to r squared plus 91 squared. R squared, this is, we have already got it in the previous case, right? R squared is equal to r squared plus x squared, and s squared is equal to r squared plus 9 squared, and t squared is r squared plus 21 squared. So 3 can be rewritten as r squared plus 91 squared negative r squared plus x squared, and then equal to s squared is r squared plus 9 squared, t squared is r squared plus 21 squared. So what I wish to do is I would like to simplify this. So if you were to expand this, you get r squared plus 91 squared negative r squared negative x squared r squared plus 9 squared negative r squared negative 21 squared. They get cancelled. These also gets cancelled. So you have 91 squared negative 9 squared positive 21 squared is equal to x squared. So 441, I take away 81 from that, 360. So this is going to be 360 added up with 91 squared. (8641) we are getting. So plus 91 squared will give me x squared is equal to 8641. So therefore x is equal to root of 8641. So what is that? Root of 8641. So x value is approximately 92.96.